Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 27th video lecture on the course Applied Artificial Intelligence. Today I am going to discuss about the fuzzy sets in fuzzy logic. These are the topics to be discussed today. What is the meaning of fuzzy set? And what are the operations as well as few properties on the fuzzy set. This is the topic learning outcome for fuzzy sets. So after the completion of this topic, students can understand the concept of fuzzy sets to handle uncertainty and vagueness. Already I have discussed in my previous videos during the introduction of the fuzzy set, as well as the last video I discussed about the crisp set also. Especially the fuzzy sets are applicable to handle the uncertainties. Uncertainties means the data or the knowledge which does not have the exact information or the precise information. Those kind of things can be handled by the fuzzy set. The set theory of classical is the subset of the fuzzy set theory. That is what I have discussed in my previous video, like in the crisp set theory, which is nothing but the normal or the standard set theory, which is a subset of the fuzzy set theory. So fuzzy logic is based on the theory which is a generalization of the classical set theory. I mean the crisp set. The fuzzy set is a collection of the values which exist between 0 and 1. Because as I discussed before, the crisp set is called as the Boolean logic, or the Boolean set which can handle only two values, either 0 or 1. Whereas the fuzzy set can handle all the linguistic terms where the membership values or the degree of truthness can be assigned between 0 to 1. Whereas the fuzzy crisp value is exactly 0 and 1. This is for crisp set, this is for fuzzy set. So curly brace means exactly 0. This is absolute false, absolute true. But whereas square bracket means the values ranges between 0 to 1. So maybe 0, 0.1, 0.2 up to 0.9, then 1. So fuzzy sets are denoted or represented with the tilde symbol. That is the representation normally in many websites you can see, or many textbook you can see. Somewhere it may be given normal set or normal set A, or else you can write like this tilde symbol A. So fuzzy sets are denoted or represented by the tilde character, which the sets of fuzzy theory was introduced in 1965 by the mathematician and computer scientist Lopti A. Zadi. Then what is fuzzy set? So in the fuzzy set, the partial membership exists. Partial membership means the degree of truthness varies between 0 to 1. So this theory is released as an extension of the classical crisp set theory. Now we can define, now we will see how mathematically we can represent the fuzzy set. Already I have discussed in my previous video how mathematically we can represent the fuzzy is the crisp set. Normally for the crisp set we used to use f of a. If a is the crisp set and the characteristic function for the crisp set we can represent with the symbol f of x. X is an element of the set A that can be represented as, that is equal to x, as that x is equal to 0 or x is equal to 1. When x is equal to 0, if x belongs to A, and when x is equal to 1, if x does not belongs to A. So this is a representation of the crisp set, whereas the fuzzy set mathematical representation is like this. So this theory is denoted mathematically as a fuzzy set like this. A tilde symbol is a pair of U and M, where U is nothing but the universe of discourse and M is nothing but the membership function. In the next video lecture, I will discuss about all the membership functions, how we can define for different situations. So for the time being, you just remember U is nothing but the universe of discourse and M is the membership function, which takes on the values between 0 and 1. So the universe of discourse U is also denoted as, we can write with omega symbol or we can write capital X symbol. Any symbol you can take it, but it should be capital. Now, the fuzzy set we can represent using the A tilde bar, that is equal to X comma mu of Here the mu is nothing but the membership function. This is called as membership function for the Fauci set. So mu of a tilde bar of x, that means x is the element of the Fauci set, and mu of a tilde bar of x is nothing but the membership function of this element, such that x belongs to x. That means this small x should belong to the universe of discourse. Did you understand what I have said? The representation for this membership of the Fauci set we can represent using the tilde symbol a. If a is a Fauci set, then a membership the Fauci set we can represent a tilde symbol, that is equal to x is an element. This is a small element or the element of the Fauci set, and its membership value can be represented as a tilde symbol of x. That means a tilde symbol is nothing but the Fauci set, and mu is the membership function, and x is the element. So for this element x, we are defining this is the membership value or the degree of truthness, such that x belongs to x. X is nothing but the universe of discourse, right? So this is the representation for the Fauci set, mathematical representation for the Fauci set. Now let me discuss various operations on the Fauci set. Suppose A and B means A tilde bar and B tilde bar are two Fauci sets, and X is nothing but the universe of discourse. Then these two are the membership function for these two Fauci sets, A tilde bar and A B tilde bar. So mu of A of X, mu of B of X. These are the two membership functions or membership values. Then the operations, there are three operations can be performed on the Fauci set. The first one is the union operation, second one is the intersection operation, and third one is the complement operation. Let me discuss what is the union operation, how it can be performed on the Fauci set. It is not similar like our classical union operation. It is little bit different here. The union operation of the Fauci set is defined by A union B of X, that is equal to max of mu of A X and B. Here I have written, I have not written the tilde bar. You can write, so you can write A union B of X. X is the element of this universe of discourse. That means we can take, that is a maximum of mu of A X comma mu of B X. So X should belong to both A and B, and these two are the membership values of both the sets. Now we can see the example for the set union operation. Let us suppose A is the set A which contains the following elements. A is the set having x1, x2, x3 and x4. These are the elements, and here it is written that 0.6, 0.2 and 1 and 4. That means 0.6 is nothing but the degree of truthness for the element x1. 0.2 is the degree of truthness for x2, 1 is the degree of truthness for x3, and 0.4 is the degree of truthness for x4. Similarly, B is also a set which is containing these elements x1, x2, x3 and x4. x1, the degree of truthness, so the membership value for x1 is 0.1, membership value for x2 is 0.8, and membership value for x3 is 0, and membership value for x4 is 0.9. Then how we can find A union B is equal to this x1 comma 0.6. You can observe here there are two values which are assigned in each combination. One is the element as well as its membership, whereas in our normal CRISPR operation we used to consider only the value. Here the value means the element is x1 and its membership value we need to consider for all the elements. x1, x2, x3, x4 are the elements and their corresponding membership value. Same thing for B set, x1, x2, x3, x4 are the elements and their membership value. So how we can find the A union B? As per the formula, mu of A union B of X, that is equal to max of mu of A X comma mu of B X. That means we can write here, this is the representation like mu of, let me write over here so that you can understand, mu of A union B of X, that is equal to max of mu of A X comma mu of B X, right? This is the formula. Now for the first we will consider this element and this element from both the sets A. So I can write mu of A union B x1. So that is equal to max of mu of A x1 and mu of B x1. So what is the max of both the values for, because x1 is common in this pair for A and B. What are their values? Max of mu of x1 is 0.6. Right, and mu of B x1 is 0.1. So what is the maximum value between these two? That is equal to 0.6. That is why we are getting this one, x1 comma 0.6. Similarly for x2, what is the membership value? 0.2, and here it is 0.8. What is the maximum? So 0.8. Similarly for these two, x3, 1 and 0. What is the maximum value? Is 1. And here we are getting for x4 it is 0.4 and 0.9. So what is the maximum value? It is 0.9. So like this we have to find out the maximum between the membership values of each element for both the sets. Then intersection operation. The intersection operation of the Fuzzy set can be defined as A intersection B of x is equal to, instead of max in case of the union we are taking max, but here we have to take the minimum between two membership functions. So mu of Ax comma mu of Bx. Now same example here we will take the, suppose A is the set having 4 elements x1, x2, x3 and x4 and having their membership value 0.3, 0.7, 0.5 and 0.1, and B is also a set or the Fuzzy set having 4 elements x1, x2, x3, x4 having their membership value 0.8, 0.2, 0.4, 0.9. So as per the formula for the intersection operation, this is the formula. So we can write mu of A intersection B. We have to find mu is the membership. Mu is nothing but the membership function or the Fuzzy set function we can say. So of x, that is equal to minimum of mu of Ax comma mu of Bx. Now instead of x, if I write 1, here it is 1, here it is 1. So what is the value for the first case for this one and this one? So minimum between what is the membership value here? 0.3. Let me write. So mu of x for x1, what is the membership value? It is 0.3. For x1 here for B set 0.8. So what is the minimum value here? 0.3. Same thing for the next one, 0.7 and 0.2. What is the minimum value here? 0.2. Here 0.5 and 0.4. Minimum is 0.4. 0.1 and 0.9. So minimum is 0.1. So like this we can find the minimum value between two Fuzzy sets using their membership or the degree of truthness. And the third one is the complement operation. The complement operation of the Fuzzy set is defined by the symbol mu of A tilde bar of x, that is equal to 1 minus mu of Ax. So now you can see as the complement it requires only one set. So we are considering one set having 4 elements x1, x2, x3 and x4 having all the membership values. For x1 the membership value is 0.3, for x2 the membership value is 0.8, for x3 it is 0.5 and x4 it is 0.1. So A bar it would be the value. So as we know the formula for mu of the complement operation, we can write over here mu of Ax, that is equal to 1 minus you can write the tilde bar for Fuzzy set, 1 minus mu of Ax. So if you subtract, so everything, all the membership value we have to subtract from 1, then only we can find. So what is the membership value for x1? 0.3. So 1 minus, so if I write x1 over here, so for the first element we will calculate 1 minus 0.3. So it would be 0.7. Similarly, for second one, 1 minus 0.8, it would be 0.2. So like this we can calculate, right? So this is 0.2, it would be 1 minus 0.5, it would be 0.5, 1 minus 0.1, it would be 0.9. So like this we can calculate all the values for complement operation using membership values. There are various properties of the Fuzzy set. One is the evaluation properties, commutative property, associativity, distributivity, and absorption, idempotency, which is called as the tautology, identity, transitivity, and De Morgan's law. So evolution, involution means the double complement. Involution states that the complement of the complement is the set itself. So A complements its complement is nothing but the set A. Commutative, as we have already discussed in the CRISP set, the same operations are applicable in the Fauci set also. Operations are called as the commutative if the order of the operands does not alter the result. So Fauci sets are commutative under union and the intersection. A union B is equal to B union A and A intersection B is equal to B intersection A. Associativity, normally it requires three finite sets. Associativity allows the changes in the order of operations performed on the operand. However, the relative order of the operand cannot be changed. Means their order, the order how we write the left side, the ordering will not be changed. All the sets in the equation appear in the identical order only. The Fauci sets are associativity under union as well as the intersection. It is applicable for both the union operation as well as intersection operation. That means A union B union C, that is equal to A union B union C, and A intersection B intersection C, that is equal to A intersection B intersection C. The fourth one is the distributive operation. Just we have to open the bracket and we have to simplify. It also requires three finite sets. If A, B and C are three finite sets, A union B intersection C, that is equal to A union B. We are opening the bracket and simplifying. A union B intersection, then A union C. Similarly, A intersection B union C is equal to A intersection B, then union, then A intersection C. So this is what the distributive property. The normally we used to use in the mathematics also. Same operation. Absorption property says that it produces the identical sets after stated union and intersection operation. A union A intersection B, that is equal to A, and A intersection A union B, that is also is equal to A. Idempotency, which is called as the tautology also. Idempotency does not alter the elements or the membership values of the elements in the set. A union A is equal to A and A intersection A is equal to A. Then identity property, A union phi, that is equal to A. Phi is nothing but the null set here. A intersection phi, that is equal to phi. A union X, X is the universe of discourse, that is equal to the X. A intersection X, that is equal to A, the set itself. Then transitivity, it requires three finite sets. If A is a subset of B and B is a subset of C, then we can say A is a subset of C. De Morgan's law, already we know why it is used, especially De Morgan's law are applicable for both union and intersection. In the set operation, De Morgan's laws are used to simplify the complex set operations. So the complement of these are the two laws. Theoretically, it is written, the complement of the union is the intersection of the complement of individual sets, and the complement of an intersection is the union of the complement of individual sets. So mathematically, we can represent like this: A union B complement means bar, that is equal to A complement intersection B complement, and the second law says that A intersection B complement, that is equal to A complement union B complement. This is what about this video. I hope you might have understood regarding the Fauci set, why the Fauci set is used, and what are the properties and the operations on the Fauci set. Three important operations I have discussed: the union operation, the intersection operation, and the complement operation. The operations are not similar to the normal classical set operation. The operations are a bit different here. We have to taking into consideration about the membership values of each element, then only we can find out the union, intersection, and complement. So for the preparation of this video, I have taken the reference of this book. The first book is the Sarosco book for artificial intelligence, as well as I have taken the help of this YouTube channel, which is displayed on the screen. Next class, I will discuss about some few more topics about the Fauci set, like the membership function as well as the Fauci hedges. And one more important topic is there, that is related to neural network. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.